And now we are going to look at the idea of quantifying species dispersion. So what is the number? How do we indicate if a species is uniformly dispersed compared to randomly dispersed? And the idea here is that we utilize an equation for this. And the way we do it is by looking at one large area and breaking it into subplots. So here we have one big plot, one big area that we're looking at to find the dispersion pattern of this plant called duck's foot. It's a forest understory plant that's native to the Pacific Northwest. So here we have 4 subplots. The first subplot we have 2 plants in it. The second one we have 7. The third and fourth we each have 4. And that totals up to 17, by the way. So 17 individuals of duck's foot is within this large plot. So this equation calls for the fact that we count out the total number of plots, which were 4, and then the number of individuals of one species in a single plot. So when I said subplot 2, that would be x. So x is 2 for subplot 1. And this symbol sigma here means that you add them all up. So you add up all the x's squared. So that's the whole idea. So you take 2 and you square it, and then you add it to 7 squared, you add it to 4 squared, and you add it to 4 squared. And then you come out with this number right here. And then we subtract n, which is the total number of individuals in all plots. So that totaled up to 17. And then you will get a value that is or is roughly around 1. And that indicates your type of dispersion. So it gives a number to a pattern. If it equals 1, it's randomly dispersed, and that's hard to get exactly 1. Again, it's the rarest form that's found in nature. And if it's less than 1, it's uniform. If it's more than 1, it's clumped. So let's do a quick little run through here. So again, take a picture, take it in, try to memorize this. Nah, you don't have to. So here we counted it out for you. So in the equation, little n is the number of plots, which is 4. And then when we were to square each one of the subplots, each number of plants in each subplot, you end up with 4 plus 49 plus 16 plus 16, which totals 85. And that's the number right here. And we subtract the total number of individuals within the entire area from that number. And the denominator is composed of the number of individuals in the entire area times the number of individuals minus 1. So in this case, it's 17 times 16, which gives you a total denominator of 272. And in this case, 4 times 68 equals 272. So then you have 1, which, relating it back to the values of the dispersion index, it's randomly dispersed. So in this case, duck's foot is randomly dispersed within this area. And the reason why we need an equation like this is you couldn't say that it was randomly dispersed just by staring at this. You could even say that it was, maybe clumped in this corner. Or if you're not practiced at evaluating this, you could even say that it's uniformly dispersed. So the number gives us a quantitative and definite value and characteristic on the dispersion types of a certain species. So one thing you can do is go through here, use the slide stacks that are in PDF format that have been uploaded to D2L, and carry out these 2 practice equations or scenarios. And the nice thing about that is we walk you through it. So you'd be able to see exactly what you did wrong or if you did it exactly right. So mainly from this presentation, the idea is to get you to start thinking differently about the environment around you. So that's at a region scale. So how are the ecosystems around you different from what they used to be? How have humans affected them from, say, pre-colonial times? And also, you can relate this lecture to your site by these questions to kind of relate if your site contains species with clumped, random, or uniform distributions, as well as you can most likely, if you don't know already, indicate if your site had been disturbed in the past passed based upon the distribution of species as well as the type of species there. You need to think, are they early successional, are they weedy, are they invasive, or is it old growth? Or is this actually a pristine site that has not been touched? And one way to know if it's pristine or not is to look for these sites which are most likely preserved by the state or county that you live in preserves or parks. So all I have to do is do a quick Google search looking for old growth habitats within your area. And I also attached 4 readings that I find very, very helpful, and it's a great way to expand upon what you learned today as well as from lecture. And the idea here is that you don't stress the technical wordage. These are scientific papers, and you will need to look some of these up to reference in your final paper or project that you'll be submitting. But the idea is to expand upon what you've learned today and basically see how it's employed in different ecosystems and through scientific research. So thank you so much, and hopefully this helped.